Creating an abstract class in C++ without pure virtual functions. In the world of C++ programming, the concept of abstract classes is a cornerstone for implementing polymorphism. An abstract class is typically understood as a class that cannot be instantiated on its own and is usually achieved through defining pure virtual functions. However, seasoned developers might wonder, is it possible to create an abstract class in C++ without adding pure virtual functions? The answer involves some creative programming techniques. The traditional approach with pure virtual functions. Before diving into the alternative method, let's briefly recap the traditional approach. Typically, in C++, an abstract class is created using pure virtual functions. A pure virtual function is defined by setting its declaration to 0. Here's an example. This makes abstract base an abstract class, meaning it cannot be instantiated. Derived classes must implement the print function to be instantiated, making a class abstract without pure virtual functions. An abstract class can also be created by providing a protected constructor. By preventing instantiation from outside the class or its subclasses, you can achieve abstraction. How does it work? Protected constructor. By declaring the constructor protected, you restrict object creation to derived classes only. This is because constructors that are protected or private cannot be accessed directly if attempted to instantiate, thus achieving the goal of an abstract class. Virtual methods. Although we have not declared any method as pure virtual, it remains virtual, allowing polymorphic behavior if expected from derived classes. Benefits and considerations. Design flexibility. This approach offers a flexible class design, allowing developers to make assumptions about the inheritance hierarchy without enforcing strict interface contracts through pure virtual methods. Maintenance and scalability. Adding a pure virtual function mandates that all derived classes must implement that function. If the functionality of derived classes is expected to evolve, starting with protected constructors offers room for extension. Risk of undesired behavior. Despite flexibility, this method can make it less explicit that the class is abstracted primarily for an inheritance and not intended for direct usage, which could lead to misuse without clear documentation. Conclusion. While conventional wisdom may lead many developers to believe that pure virtual functions are necessary for creating an abstract class in C++, this method of using a protected constructor highlights the creative versatility of C++. Understanding these advanced techniques provides a broader toolkit for designing robust, scalable applications. Embrace these patterns when they align with your design intentions, but always strive for clarity and comprehensibility in your codebase to maintain accessibility for other developers or future you.